Good morning, all of you. Today, we are going to learn about the luting cements. This is a very vast topic. We are going to cover it in 3 to 4 parts. Introduction. The industry uses a wide range of the cement to retain the crown, posts, and the fixed partial tension with the toothless structure. Classes of dental cements have evolved from the zinc phosphate to glass ionomer, resin modified glass ionomer, resin cements, and lastly, to self adhesive resin cements. Since metal, force infused to metal, resins, and all ceramic restoration are used today, an understanding of the cement performance is needed before selecting a material to use in a particular situation. The word luting is derived from the Latin word lutum, which means the mud. The dental luting agent provides a link between the restoration and the prepared tooth, bonding them together through some form of surface attachment, which may be mechanical, micromechanical, chemical, or combination of both. History for the luting cements. These are the chart. Uh, I get it from the International Journal of the Dentistry. You can see from 1818 to the recent 2009 how the luting cement has been evolved from acid-base reaction cement to hybrid acid-base reaction. We are going to cover the luting cement under all this topic. We are going to study all this topic: the zinc phosphate cement, the silica cement, polycarboxylate, composite resin, glass ionomer cements, resin modified glass ionomer cements, ceramide, and the self etching. These are the chronological order how the luting cement is evolved. These are the general information. 1873, the silicate cement by Fletcher. 1873, the zinc oxide and the clove oil by Chilson. 1879, the zinc phosphate cement by Dr. Pierce. 1930, the calcium hydroxide paste by the Dr. Herman. 1968, polycarboxylate cement by Dennis Smith. In 1971, the glass emerald cement by the Wilson and the Kent. This is the uh, important one to remember. The glass emerald cement by the Wilson and Kent. We are going to discuss some ideal qualities which all cements, luting cement should inhabit in order to reach the smallest detail between the restoration and the tooth. It should possess low viscosity and the film thickness and low film thickness. It should be resistant against the mastication forces, cooling forces formed through the effect of gummy foods. It should provide sufficient heat insulation to protect the living tooth or vital tooth from the thermal effects. It should be able to bond to the hard dental tissues. It should have a long shelf life. It should give the sufficient working time and be easy to manipulate. Uh, the luting cement should have the sufficient working time and the mixing time and of course the setting time. These are the journal how the lutein cement should attach with the abutment process interface. When two relatively flat surfaces brought into contact, the space exit between on a microscopic scale. There are peaks and the valleys, as you can appreciate in that on the diagram. They are the only point contact along the peaks. Main purpose of the cement is to fill this space completely. If the cement is not fluid enough, void can develop around deep valleys. Classification. These are the general classification given in the different books. Just showing the based on the chief ingredient, based on the matrix bond type, based on the knowledge and experience of the use, based on the principal setting ratio. These are given in the different books, Craig, O'Brien's, Donovan, and the Wilson. They're based on the chief ingredient, zinc phosphate, zinc silicophosphate, zinc oxide eugenol, zinc polyacrylate, glass ionomer, and resins. Based on the matrix bond system, phosphate, phenolate, polycarboxylate, resins, and resin modified glass ionomer. Based on the knowledge and the experience of the use given in the Donovan, a conventional and temporary. Under the conventional, the zinc phosphate, polycarboxylate, and the glass ionomer. Contemporary, the resin modified glass ionomer resins. Based on the principal setting reaction, Wilson, and given the Wilson, the acid base reaction and the polymerization reaction. We are going to cover the whole topic uh, under this classification. So, what are these the luting cements? First one, we are going to cover the zinc phosphate cements. Oldest of all the luting cements, given in comes in the 1878, and this is the standard with which the newer material can be compared. The zinc phosphate cement, the oldest of all cements, powder in the given in comes in the powder in the liquid form. It occurs in the E acid and the base reaction. Powder are the zinc oxide. The content of the powder are the zinc oxide and the magnesium oxide. Zinc oxide is 90%, magnesium oxide is 10%. Liquid, the phosphoric acid, water, aluminum, and the zinc phosphate. The setting reaction, when the powder is mixed with the liquid, phosphoric acid attacks the surface of the particle and releases the zinc ions. Aluminum in the liquid is essential force to form a gel. The aluminum complexes with the phosphoric acid and the zinc ions to form a zinc aluminum phosphate gel. This reaction gives the heat. That is why it is also the exothermic reaction. The set cement is core, the structure consisting primarily of the unreacted zinc oxide particle embedded in a cohesive amorphous matrix of the zinc aluminum phosphate. For this reaction, the water is critical to present. The mixing technique is critical in developing the optimal cement and should be completed on a cool slab over a wide area to incorporate the small increments of powder into the liquid for approximately 1.5 minutes. Mixing time is approximately 1.5 to 2 minutes. Setting time is 5 to 8 minutes. More the powder, more the strength. It doesn't mean that we should add the more powder. Some qualities for the zinc phosphate. The compressive strength 80 to 110 MPa and tensile strength 5 to 7 MPa. High modulus of elasticity of 13 ZPa of properly mixed cement, which permits the cement to resist elastic deformation in the region of the higher masticatory stress or in the long span prosthesis. The prosthesis that spans from 4 to pontic and the two abutments. The axis should not be removed for at least several minutes after the initial hardening to reduce the risk of saliva contact, as the zinc phosphate is very soluble in the initial setting stage. Post cementation of hypersensitivity is indeed a frequently occurring clinical problem. A mixed cement is at a very low pH, hence the smear layer should be maintained to minimize the penetration into dentinal tubules. This can give the hypersensitivity. This is the cause for the hypersensitivity. The cavity varnish may be used to reduce the effect of low pH on the pulp. Second one is the silicates. Introduced in 1903 as anterior filling material. This is one of the aesthetic materials, cement, luting cements, filling cements. Powder contain silica, alumina, chloride compounds, and a calcium salts. Liquid contains the phosphoric acid, water, and buffer salt. Silicates are attacked by the oral fluid and in time degrades. This may not be considered permanent restoration. Okay? The use of the silicate cement diminished with the advent of the composite resin and development of the GSM. This one was for the aesthetic region for the anterior filling, but of course, because of the oral solubility of the oral fluid, it is not used now. Advantages: it exhibits the good aesthetic qualities, anti-carcinogenic property, analogs to topical applied fluoride solution. Disadvantage: it lacks the solubility in oral fluids with a loss of aesthetic quality, irritant to pulp. Third one, the zinc oxide eugenol, given by Dr. J. Foster Flagg in 1875. This cement was developed from the zinc oxychloride cement by substitution of the liquid with first with the creostate and second with the eugenol. The first proprietary Zedoy product, the commercial product, was the Pulpol, introduced by the Wessler in 1894. The various additives have been combined with the zinc oxide eugenol cement to improve its strength and reduce solubility. Examples: silica, alumina, rosin, calcium phosphate, polystyrene, polymethyl methacrylate, and ortho-ethoxybenzoic acid (EBA). Type 1 ZOE for the temporary cementation. Type 2 ZOE for the permanent restoration cementation. Type 3 ZOE for the temporary filling material and thermal insulation. Type 4 ZOE the cavity lining. The component for the zinc oxide regional, the zinc oxide 69%, white rosin 29.3%, zinc stearate 1%, zinc acetate 0.7%. The zinc oxide is a principal ingredient. White rosin that reduces the brittleness. Zinc stearate the accelerator and act as a plasticizer. Zinc acetate accelerator and improve the strength. And sometimes magnesium oxide is also added. Liquid composed of the eugenol 85% that breaks with the zinc oxide and the olive oil 15% act as a plasticizer. Setting reaction. First, the hydrolysis of the zinc oxide to its hydroxide. What is essential for the reaction to proceed reaction in an acid base? Zinc hydroxide combines with the eugenol to form a chelate, that is zinc eugenolate. Forms It forms an amorphous gel which later tends to crystallize. Structure: the particle of unreacted zinc oxide embedded in the matrix of the zinc eugenolate. Setting time 4 to 10 minutes. Complete setting reaction between the zinc oxide and the eugenol takes place about 12 hours. pH is 6.6 to 8. They inhibit the growth of bacteria, have an anodyne or the soothing effect on the pulp. Relatively weak cement. The compressive strength ranges from 3 to 4 MPa to 50 to 55 MPa. Solubility of the set cement is high. This integrates in the oral fluid. Some of the other variants for the zinc oxide eugenol, that is the use of the vanillic acid 4-hydroxy 3-methoxy benzoic acid ester in which the liquid is composed of the 12% anhexyl vanillate EBA with a powder containing zinc oxide, alumina, and hydrogenated roses. Replacement of the eugenol by vanillate resulted in the odorless cement with high strength, low solubility, and no inhibition of the vinyl polymerization. Addition to the non-noble metals and polymers is good, but the minimal to enamel and dentin. Addition Additional pure silicon Z zinc oxide cement with a silane agent, non-eugenol cement. It is formed yet elastic temporary cement, insoluble in the oral fluid, which cleans up easily by peeling off. It is available commercially in an atomic syringe kit. The eugenol free cement with a calcium hydroxide. It is bacteriostatic and support the formation of the secondary dentin. It is available as a quick mix syringe, cartridge, and the tube. Other variants for the zinc oxide eugenol EBA and the other chelate cements are zinc powder, the zinc oxide alumina, fillers for 20 to 30%, hydrogenated rosin 6%, liquid or ethoxy benzoic acid 50 to 60%, eugenol remaining part. Uh, all the remaining part of form as eugenol. Manipulation: the powder is added into the liquid in a bulk and kneaded for 30 seconds, and then stopped for additional 60 seconds with the broad stroke of the spatula to obtain the creamy consistency. Film thickness 25 to 75 micron. Compression strength 35 to 45 MPa. Tensile strength 4 MPa. Setting time 7 to 9 minutes. Working time 5 minutes. Mixing time 2 minutes. These cements are increasing in popularity as a retrograde filling material. Resin and for zinc oxide eugenol cement contains the zinc powder 80%, polymethyl methacrylate 20%, zinc acetate, zinc acetate, thiamol, and hydroxyquinoline. Liquid content again the eugenol and the olive oil. The aim is to improve the strength and reduce solubility of the cement. High strength and low wear make them the ideal intermediate restrictive cement. After all this verification for the zinc oxide eugenol and the changes in the liquid and the powder, there's still some drawbacks for this. The deterioration and the breakdown occur even after, with the modified material. So their use is confined primarily in situations in which the tooth sensitivity is a problem and a short-term gluten cement for provisional acrylic crown and fixed partial denture. Now, the zinc polycarboxylate given by Dr. Dennis Smith, a Manchester, situated in the Manchester in 1968. Uh, this polycarboxylate is from around 1960. Adhesive, it is the first one, the adhesive bond to the fruit structure. Comes in the powder and liquid form. Zinc oxide contains the zinc oxide, powder contains the zinc oxide 72%, magnesium oxide 7%, other oxide like bismuth and aluminum, stainless fluoride, and other stainless fluoride. Liquid contents are the liquid solution of the polyacrylic acid 32 to 48%, copolymers of acrylic acid with the other unsaturated carboxylic acid, ketogenic malic and carbonic acid. Ketogenic and the tartaric prevent the gelling. When the acid comes in contact with the powder, acid reacts and releases the zinc, magnesium, and tin ions. They bond to the polymer chain through the carboxyl group. This ion also react with the carboxylic group of the adjacent polyacid chain. Cross-linked salts are formed. The cement bond chemically to the tooth structure. Polyacrylic acid react with the calcium ion via carboxyl group on the surface of the enamel and the dentin. These are the diagrammatic show how the cement forms or gel form. Bond strength. This is the reaction. The bond is still greater on the enamel than the dentin. Film thickness of 25 micron. Zinc polycarboxyl exhibit the pseudoplastic behavior. Action of the spatulation and seating reduce the viscosity of the cement. Working time 2.5 seconds. Working time is much shorter than zinc phosphate 5, that is 5 minutes. Second time is 6 to 9 minutes. Compressive strength 66 to 77 MPa. It is not brittle as the zinc phosphate cement. The solubility of the cement is in water is low but increase in the organic acid. Biological consideration. The pulpal response term as a mild. pH of liquid is 1 to 1.7. The freshly mixed cement is 3 to 4. The pH freshly mixed cement is 3 to 4. And after 24, it is 5 to 6. The reaction, the manipulation process is given. A full glass slab of the powder, 1.5 part of the powder to 1 part of liquid by the weight. Liquid not dispensed before the start. The loss of water to atmosphere increase the viscosity. Powder is rapidly incorporated into liquid in large quantities. Mixing time is within the 30 to 60 seconds with half to all the powder incorporated at once to provide the maximum length of the working time. Glossy appearance. When the mix is a glossy appearance, the acid present to provide a sufficient carboxylic group of the bonds. Dull appearance of the mix. Insufficient number of the carboxylic group present to bond the calcium in the tooth structure to the surface. Surface preparation. What are the preparation done before the cementation? Zinc polycarboxylate is not superior to zinc phosphate cement. Failure occurs usually at the cement metal interface. During removal of the excess cement, during setting, zinc polycarboxylate passes through the rubber stage. Aim is to remove the excess cement as soon as the setting is complete or once the cement becomes hard. So, this is all about the zinc. This is all about for Luting cement for now, for today. In the next lecture, we are going to discuss about the glass ionomer, the resin glass ionomer, and the third part we're going to discuss about the self-adhesive cements. Okay, thank you.